Hello viewers, you are welcome back to the channel Tyndanius Math and Science Tutorials, where we are going to continue. We are still under the business of solving questions. We want to really appreciate the relevance of this gas laws. So today let's consider two questions. The question reads, a cylinder with a movable piston contain 2.00 gram of helium, that's He, at room temperature. More helium was added to the cylinder and the volume was adjusted so that the gas pressure remained the same. How many grams of helium were added to the cylinder if the volume was changed from 2.00 liters to 2.70 liters, given that the temperature was held constant and we're given the molar mass of helium to be equal to 4.00 gram per mole. So this is all about Avogadro's law. We said that for Avogadro's law, at constant temperature, we said the volume of the gas is directly proportional to the number of moles. So V is directly proportional to what? Number of moles. So if this is so, then V equals Kn. Please, if this is your first time, go and watch my video on Avogadro's law. I've explained them over there. When I make constant K the subject, the K equals V over N. So V over N equals what? A constant. So have my V over N equals constant. It doesn't change. So I'll still repeat it over here, V over N. So if you have V1, N1, here will be V2, N2. So that means we are going to employ this formula when it comes to Avogadro's law. So let's write our data down and see what we are going to do. And also remember, for number of moles, so amount of substance N is equal to, in terms of their masses, you have the mass over the molar mass. Where mass is measured in grams, the molar mass is measured in gram per mole, and the N, or the amount of substance, is measured in what? Moles. Okay, so the question reads, a cylinder with a movable piston contains 2.00 gram of helium. So therefore, the mass of my helium here equals what? 2.00 what? Gram. At room temperature, more helium was added to the cylinder and the volume was adjusted so that the gas pressure remained the same. How many grams? So which means they are asking for another grams. So we have the first gram, which is the mass, and the second one. So I'll call this M1, and I'll call the new gram that they are saying I should find. How many grams? So M2, which is equal to what I'm looking for. I don't know. How many grams of helium were added to the cylinder if the volume was changed from this to that? So if the volume is changing from this to that, that means this is my initial volume. So my initial volume will be V1 of, that's my helium, equals what? 2.00 liters. Then 2. So the final volume, that's V2, equals what? 2.70 liters. And I was given the molar mass of the helium to be equal to 4.00 gram per mole. With this, I can employ the concept of Avogadro's law. So if I have M and big M, what relationship do I have? So you know that N is equal to what? Small m over what? My big M. So here I'm dealing with the 1, the initial. So I'll say N1 is equal to what? My M1 over my big M. So my N1 equals, what is my M1 here? The question is what? Is 2. So I have my 2 over my big M, which is what? 4. So I have what? Half. So therefore my N1 of my He helium equals what? 0.5 mole. For this, though we still know this, the molar mass, but we don't know the mass. So therefore, we will have to find the number of moles for M2 and convert it to mass. So how do you do that? That's why we are going to employ the concept of Avogadro's law over here. What Avogadro's law is stating that the volume of the gas is directly proportional to what? Number of moles. So therefore, I can say, so employing the Avogadro's law or concept, are saying that V1 over my N1 should give me V2 over what? My N2. So let me do substitution. Do I know V1? Of course, yes. Which is what? My 2 all over my N1. My N1 here, that's what I have calculated for to be equal to what? My 0.5, which is equal to my V2. Where is my V2? My V2 here is what? Fortunately for me, I've been given to be 2.70 all over my N2. I wasn't given N2, so N2 is the unknown variable to be found. So therefore, if I make N2 the subject, N2 will give me 0.5 multiplied by 2.70 all over 2, and by the help of the calculator, we are getting 0.675 mole. Yeah, mole. By the help of the calculator, that's what we are getting. So this is the number of moles of the helium. That's 0.675 moles. So now, but the question goes on to say how many grams of helium were added. Before we find for the magnitude of the grams being added, first of all, we have to convert this to mass. So we know the relationship that N is equal to small m over what? My big M, right? So therefore I can say N2 is equal to what? My M2 over what? My big M. So now I know N2 here, so I'll make M2 the subject. So therefore my M2 here, if I make it the subject, I'll get N2 multiplied by what? The molar mass. So therefore the mass of the helium here will be, what is my N2? My N2 here is what? I have 0.675 times the molar mass, which is what? The molar mass in the question is 4. So by the help of the calculator again, we are getting 2.7 grams. 2.7 grams. So this is the mass. But the question says how many grams of helium were added. So we want to know the magnitude of the grams of the helium being added to the cylinder. So what do we do? So we know that we have the mass, we have two masses here. So to be M2 minus M1, so that change in mass will give you, this change in mass will give you a magnitude, and that magnitude is equal to the mass being added to the cylinder. So therefore my M2 here is what? Is 2.7 minus 0.what? Minus my M1 in the question is what? Is 2. So clearly I'll get 0.7 what? Grams. So viewers, this is, so they say how many grams of helium were added to the cylinder. So this is the magnitude of the grams. That 0.7 grams was added to the cylinder. So this is the answer to the solution. Okay, let's attempt the second question over here. Now, a flexible container at an initial volume. So I have my solution over here, we are saying an initial volume. Initial means first. My first volume. So that would be what? V1 equals 5.12 liters. Contains 8.5 moles. So if this is V1, the number of moles N1 equals what? Have 8.5 what? Mole of gas. We are saying more gas is then added to the container until it reaches a final what? Volume. A final volume. So the final volume what? V2 equals what? 18.1 what? Liters. Assuming the pressure and temperature of the gas remain constant, calculate the number of moles of gas added to the container. Here we were even fortunate enough to calculate the number of moles. They didn't talk about mass over here. So we can straight away employ the Avogadro's law, which says that Avogadro's law says that V1 over what? By N1 should give me what? V2 over what? By N2. So what am I looking for? So N2. As I said, calculate the number of moles, the number of moles, N2. So if I make N2 the subject, I'll get N2 equals N1 multiplied by V2 over V1. So my N2, by the help of substitution, N1 is giving me what? I have my 8.5 times my V2. V2 is giving me what? 18.1 liters over my V1 is what? 5.12 liters. So therefore my N2 here is giving me the expression, is giving me the magnitude of 54.5098 moles. Yes, 58 moles by the help of the calculator. So therefore, the question says calculate the number of moles of gas added to the container. So as we did over here, were added. So we found for the difference between the first mass and the second mass, and we took the difference, right? We'll do the same thing over here. So therefore, the magnitude of the moles being added here will be I have my N2 minus my N1. So I have 54.5098 minus my N1 here is giving me 8.5, which is equal to, by the help of the calculator, let's punch this correctly to see. We have 8.5 times 18.1 over 5.12. I'm getting supposed to be 30.0488. So approximately I'm getting, let's say, 30.05. So here will be 30.0488, right? Yeah, so 30.0488 minus by 8.5, I'm getting 21.5488, and so I'm getting 21.55 mole. So this is the number of moles of gas added to the container. So if you just write down the data and know the formula to employ, whether Charles' law, Boyle's law, Avogadro's law, the ideal gas equation, the general gas equation, or what have you, then we have an assignment you have to go and perform by yourself. So the question reads, what change in volume results if 60.0 milliliters of gas is cooled from 33.0 degree Celsius to 5.00 degree Celsius. Viewers, solve this and I'll be expecting your answers. I want to see your answers in the comment section. Bye.